All right, starting with step number 1 to find YC. Okay, the homogeneous equation as y triple prime plus y prime. So the auxiliary equation will be m to the third power, the third order, plus m, the first power, first order, equals 0. Okay, then we get the factor m out, get m times m squared plus 1 equals 0. We get m equals 0 as this one. And the m squared plus 1 will give you plus minus I. Okay, plus minus I. That means when m is 0, you're going to get the solution y equals e to the 0x. And the other, the m equals plus minus, I'm going to put here as 0 plus minus 1i. You're going to get another y solution as the cosine. If you write it, it's going to be e to the 0x times cosine x plus sine x, right? So one piece is about the cosine, the other piece is the sine function. And then you have three pieces. The name is y1, y2, and y3. Okay. The conjugate complex will give you one piece is cosine, the other piece is sine. They come together as a package. So we write it in the simplified form. My y1 gonna be just the value 1. Okay, don't think too much. We do not worry about the coefficient, just the core piece of the function. Now you have three solutions. The second step, we find the Wronskian of these three functions, so y1, y2, and y3, which is a determinant of the 3 by 3 matrix. Okay, so y1, y2, y3, y1 prime, y1 double prime, y2 prime, y2 double prime, y3 prime, y3 double prime. Y1 is 1. That's pretty. So 1, 0, and 0. That's nice, right? And y2, the cosine x, derivative negative sine x, another derivative going to be negative cosine x. The third column is sine x, and the y prime of the y3 is cosine x, and the last one is negative sine x. Okay. Yeah, when you have 0, 0, many things like this, the cofactor cominor is the well, the quick way to find the determinant. But if you use the augmented method, or is the other way, it would be called the Cramer's rule, you can still use that one, but just like more columns that add to it, and also like multiply crossway down, crossway up. So this one, let's use the cofactor cominor. Since this is 0, 0, good. So we're going to target this one, which is row 1, column 1. Okay, so the sign of this going to be plus sign. Okay, we cover this column and this row and find the determinant of this one and multiply this number with this determinant to make 1 multiplied by the determinant of negative sine x cosine x minus cosine x minus sine x. Crossway down here, we get positive sine square x. Crossway up, negative of negative becomes positive cosine square. How nice. Sine square x plus cosine square x equals 1. I expect you guys to recognize this identity. Okay, sine square x plus cosine square x equals 1. Otherwise, you're going to carry complicated form along the problem. All right. And then next step, we're going to do the make sure the equation is in the standard form. Okay. Always check whether it is in the standard form or not. And the answer is yes, because the coefficient of the highest degree, or not degree, sorry, the highest order is 1. In the standard form, we can see this as a f of x, or f of x is secant x. Okay. And then we're gonna use the f of x when to find the w1, w2, w3. Step number 4, we're gonna find w1, w2, and w3. And how do we set this up? I'm gonna go to the next slide. So add another one. Note that the W is 1, right? And the f of x is the secant of x. So step number 4, we find, let's see. Yep, we're gonna find U1, U2, U3 from W1, W2, W3. So first, the W1, which is the 3 by 3, determinant of 3 by 3. W1, let me note here. So my Y1 is 1, Y2 is cosine x, and Y3 is sine x, right? So W1, so column 1, going to be 0, 0, f of x. Second column, third column remain the same for the Y2 and Y3 solution. Y2 is cosine x. No, sorry, wrong. Guess I cannot erase it. Have to use the feature on the whiteboard. Okay, so Y2, this is going to be Y2 prime, Y2 double prime as before, and this Y3 prime, Y3 double prime. So then we get 0, 0, secant x, and Y2, which is cosine x, derivative, negative sine x, and negative cosine x. Third column, sine x, cosine x, and negative sine x. Determinant. It's nice to have 0, 0 here. So we target the third row, first column, okay? And the if you recall the cofactor minor to determine plus minus sign, it's starting from plus minus plus and then alternate minus plus minus and so forth. The sign is from -1 to the power of the row plus column. And this is the third row, column 1. So the sum of row and column is 4. -1 to the fourth power, it becomes plus sign or positive 1. So that's why the sign for this, when we pick the third row, first column, gonna be positive. Positive of the secant. If we hit this row, this column, we're gonna multiply positive secant x to the determinant of the cosine x, sine x, negative sine x, cosine x. Okay, and then find the determinant of this 2 by 2 matrix. Again, this is secant x multiplied by cosine square x minus minus become plus. It's very nice. This is 1. Then the W1 is secant x. Okay, so W1 secant x, and do the same thing for W2, W3, and so forth. So let me change the color again. So W2, I'm gonna set it up and then give you the solution. I hope you can work out the detail. Okay, so W2, the first column is the same. The second column is the one that we're gonna replace with 0, 0, and the f of x, and the Y3. Column 3 will be the same. Then we get 1, 0, 0, and the second column 0, 0, secant x, and Y3 sine x, cosine x, negative sine x. And then same way as, well, same concept, but this one is much nicer because we have more zeros involved. So we have W2 as -1. So I leave the blank here for you to work on. So that W2 is -1. And W3, first column, same thing. Y1 prime, Y1 double prime. Second column, the same, using Y2. And the third column is the one that we're going to replace with 0, 0. And then the last going to be f of x. This is cosine for the second column. And negative cosine x. The last column is 0, 0, and the secant x. 0 is very nice, so gives you less thing to work on. And then the W3 will be negative tangent x. Again, I hope you guys okay with filling in to get these three terms. All right, so this is not done yet for step 4. We just get things ready to find the u prime, the u1, 2, 3 prime, and then antiderivative. More process to work on. All right, so next one, we're gonna find the u1, u2, u3, starting with the u1 prime. U1 prime, subscript 1, w subscript 1 over w. W1 is, let me look at my note, is secant x. Secant x divided by the radicand, which is 1. Therefore, the u1 equals antiderivative of the secant x with respect to x, which is natural log, absolute value, secant x plus the tangent x. Ignore the constant of integration. Otherwise, you're going to have the constant term everywhere. u2 prime from w2 divided by w, which is, okay, sorry. The w2 is positive, negative 1, sorry, negative 1 over positive 1. Just u2 prime is negative 1. Therefore, the u2 is antiderivative of negative 1 with respect to x, or just negative x. Nice, huh? u3 prime, w3 over w. w3 is negative tangent x over w, which is 1, or just negative the tangent x. Now the u3 gonna be antiderivative, put a negative sign outside. This is a tangent x dx. To find the antiderivative of this, we're gonna use the u sub. Okay, we write the tangent as sine x over cosine x with respect to x. How do we use the u sub? U is cosine x. The du is negative sine x dx. Am I going too fast? You guys okay? Follow okay?
I'm okay.
That's good. Thank you. So du is negative sine. Oh, that's nice. We have negative sine here, and the sine term is good to go. So integral 1 over u du. Then the u3 is natural log of the u, which is the natural log of the cosine x. Okay? All of them, the main part, the heavy part of the process is done. The last part, you just put pieces together. Step number 5. So your particular solution, since you have 3 solutions from the homogeneous solution, the yp going to be 3 pieces, which is u1 times y1 plus u2 times y2 plus u3 times y3. Okay, and u1 is natural log absolute value secant x plus tangent x multiplied by y1, which is the value 1, and then plus the u2, which is negative x multiplied by y2. y2 is cosine x plus the u3, or the natural log absolute value of the cosine x multiplied by the y3, which is sine x. So this is the answer for the particular solution. And then the general solution, again, same pattern, yc plus yp. And yc is the c1 times x, times 1, sorry, because the y1 here, plus the c2 times cosine x, plus c3 times sine x, and then plus the yp that we just have. Okay, so this is the general solution.